Hello and welcome to meetup number 80 for beginners Python and machine learning. Today is the first week of the month, so we'll be looking at Python for absolute beginners. And I do a couple of different ones, and this will be the first one in the series. My name's Tim Cummings, so thanks for joining me. Today you can chat to me on the YouTube chat, or you can chat on Slack. There's details how to get the Slack account on the meetup page or on YouTube page. But if you haven't done that, then yeah, feel free to chat on the YouTube chat. For people who have signed up to Slack, we'll be using the Learning to Code channel in Slack. Hi, Sean. So, if you go to the meetup page or even on the YouTube page, there'll be a link to a Google Colab notebook. And with that notebook, it's an easy way to try out Python for the first time. You don't even need to have Python installed on your computer. You can just run it all on the web, but you can also do all these exercises that we've done if you have them installed on your computer, if you have Python installed on your computer as well. So I'll click on the link, and this brings up a read-only version of the notebook. Now you need a Google account to be able to log in to Google Colab, so yeah, please set that up if you haven't got it already. And we've got here the meetup name. You see it's meetup 80. I'm Tim, and doing beginner variables and data types. So if you go to the file menu, you can save a copy in your drive, and once you've saved a copy, then you'll be able to make changes to it and run it and save it and come back to it later. So feel free to ask me any questions. Like, this is for people who've never seen Python before. I do get a few people coming back to these beginner sessions who have used Python. So if I'm not getting any questions, I might start looking at more advanced things. But it really is designed for absolute beginners, today's session. So please ask questions and make sure that I stay at a novice level. All right, so now we've made a copy of our notebook. You can see here it says copy of the meetup, and then you'll be able to make changes to that. Now, as we're going through this session, I might make changes to this one, and you might want to have a look at them. So what I'll do is I'll share the URL to this one that I'm making changes to, and so at any time you can load that in another tab on your web browser, and that way you can get anything that I've typed. So I'll just post that to YouTube and to Slack. Okay. So what we'll be looking at today, we're going to start off with interactive Python. Interactive Python is like using Python like a calculator or an instant tool for doing stuff. You're not writing programs so much. We'll be looking at data types, which is how you can save different bits of data in Python and use it later, and what types of data you can save. How we can store those in variables. We create, assign, update them. Then we'll look at a bit of scripting, which is writing little programs. So we take individual lines that we've done in interactive Python, we put them together to make a script. And we'll even look at some program structures like scripts, conditionals and loops. So challenge one is really getting Python running on your computer. So you've got options here. You can use a Google account, such as this one, and go to Colab. and that's what I'll be doing in the session today. It's a really good way of learning Python, and it's actually used quite a lot. People doing data science Python, they'll use this as their main tool. Alternatively, you can install Python 3 from www.python.org, and that's if you want to run Python on your own computer when you're not connected to the internet. You probably find some parts will run a bit faster on your computer, some bits will run slower. In fact, there's people doing data science, there's ways of tuning up their Google Colab account or even getting a professional version that will run even faster than if you were trying to run it on your own computer. Alternatively, you can install Anaconda, which is really Python plus a lot of third-party libraries. I install just straight Python on mine, and then I just add the third-party libraries that I need. I also recommend an IDE, which is an integrated development environment, and it makes coding in Python a lot easier. So it does syntax coloring, it gives you warnings about where to improve your code. Okay, so what you see here, you see there's a border around this text up here, around this formatted text. And if I scroll down and I click down here, I've now got a border around this bit of text here. And that's because each one of these is a cell in Google Colab. So these are, Google Colab uses Jupyter notebooks, so you can get this same effect if you have Jupyter notebooks running on your own computer. And so also Jupyter Notebooks is really an extension of IPython, so you might see the words IPython around, which means interactive Python. So what I'm teaching here is for Google Colab and Jupyter Notebooks, and you see a cell here. Now this is a text cell which has been formatted using Markdown format. So if I click on the cell, I can now see there's the Markdown formatting that I used, and this is what it looks like over here. And then I press Shift Enter to execute that cell, and it just converts the Markdown into text for you to see. So it's a good idea to get a little bit familiar with Google Colab. Just some of the things, the only things you really need to know how to do, you need to know how to execute a cell. So I did that with Shift Enter. You could also press like the play button on a cell, and that will also execute it. The other thing you need to be able to do is to insert a new cell, and you can see there's an insert menu up here. So you can insert a code cell by doing that keystroke there, or selecting it from the menu. If you want to look at other keystrokes, that you can define your own in these keyboard shortcuts, and if you look there, you'll see there's a whole bunch of things that you can do. So if you forget how to do any one of those, or you want to know the keyboard shortcut, you can look at that. But I'll tell you what keyboard shortcuts I'm using as I go through, and if I don't, then let me know. Just ask me and I'll let you know. That's right. So Martin asks, the notebook has been opened with private outputs. Outputs will not be saved. You can disable this. Yeah. So I like to have private outputs. I don't like saving the output when I'm doing saving my workbook, because I like it all to have empty output. If you want to change that, you can go into change runtime type in the runtime menu, and you can see here there's a little checkbox, emit code cell output when saving this notebook. So if you really want to save the code cell output, you can tick the box. For these simple notebooks, it doesn't really matter. You don't need to save the code cell output, because all you need to do is just run them all again and you'll get all the output will come back to you. But if you're doing some more data science things where running a cell can take a long time, maybe you do want to save the results, because you'll come back to it later and see what the results were. And while we're here, you can see here's the hardware accelerator. So if you're doing data science stuff, you can select a GPU or a TPU to do hardware acceleration. We're not going to need that for anything we're doing today, so it's actually better for us to select none for the hardware accelerator. Otherwise, Google will keep giving us warnings saying, why you've chosen hardware acceleration, you're not doing anything that needs it. Okay, so here's our first code cell. We've just had a couple of text cells, and this is a code cell. So this is Python code here, and it's got a little bit of syntax coloring for us. So we've created a few comments here. So the comments in Python just start with a hash, and the hash can be at the beginning of the line, and then anything after that will be a comment, or you can have it halfway through a line, and then anything from there to the end of the line will be a comment. This tells you how to bring up the IPython help, and you can see I've put a question mark here. So the question mark's in black. That's something that will actually be executed when I press the play button here. So if I press play, I'm now, question mark actually is not a Python command, it's an IPython help command. So that's one that won't work in normal Python. If you are using normal Python, then you'd use the help command. So we can see over here, it's brought up the help on the right-hand side, and it explains, and you can do question mark and a word, or just single question mark and a word, and different ways of getting different amounts of help out of the system. So say I wanted to have a look at help on the print command, I can type question mark print, and it tells me some information there about printing. Similarly, if I was using normal Python, just straight Python, I can do help and print. And that also works, it just prints the result down here rather than up there. Okay, I'll just close this help now to give my screen back. And I'll leave that. Okay, variables. Variables are places where we can store data. We can store data, we just give the variable a name, and it finds a place on the computer to store it in RAM. Of course, when the computer gets turned off, that data will disappear. But while the computer's running and you're in your console here, then you can store data in variables. So here I've decided to call my variable A, and I use the equal sign to tell me what I want to put into that variable called A, and here I want to put the number 3. So if I run that, it'll store the value 3 in the variable location A. And there we go. Oh, yeah. So number 5 tells me it's the 5th thing that's been run here. Now if I want to have a look at what is in that variable location, I can use the print command. So I can say print and A. So if I run that, this time I'm going to press Shift Enter, and that displays 3. So that's what you do in Python. If you're writing a script, you would have to use a print to display the value of something. Now, because we're using IPython, they've got a shortcut way of seeing what's in a variable. We can just type the variable name. So I'll run that, and there you go. You see 3 has come up. It's told us the value 3. Sometimes print A and just typing A will show a slightly different value, because print is really designed for outputting data into reports, while this IPython, just doing a variable name, is designed to give us a bit more information about the variable, including what type it is. But we'll see that as we go along. Now in IPython we can also just type in an expression, and so if I click run on that, my expression is A plus 4. So it's taken the value in the variable A, which is 3, it's added the value 4 to it, and it's displayed the result, which is 7. But it hasn't saved that result anywhere. That's the only place it is, just in IPython, just as a display. Now we could store the result of the expression using the equals like we did before with a equals. So we could say b equals a plus 15 divided by 4. And that would store it. It won't tell us what the result was. And then we could just type the number b on this next line, and that will show us what the result was. So I hope you're able to run these cells in your Google Colab, and you should be seeing the outputs coming here as you go down. Now, when you're naming your variables, you have to be a little bit careful. You can't use any of the Python keywords, otherwise you'll get just a straight error. You also have to be careful that you don't name your variable the same as a function or module or something else that's being used, because it will then prevent you from using that function or module. So don't get too worried about that. Like you'll only notice it when you actually try to use that function and you go, oh, why isn't that working? I've got a variable by the same name. And so if you weren't planning to use that function, then it's fine to overwrite it with a variable name. Sometimes if you're using an IDE like PyCharm, it would warn you that you've overwritten a built-in function or some other module or whatever, and so it makes it easier to be careful when you're using an IDE. But this won't tell us here, so we'll just have to just be careful. Now, to check for the Python keywords, I'm going to do something that's a little bit more advanced. You wouldn't normally do this so early on, but we're going to import a standard library called keyword, and we're going to import another standard library called sys, and we're going to use the keyword library to tell us the list of all the Python keywords. And so I'm going to do that in a print statement. I'm going to put two things in this print statement. I'm going to say the words Python keywords and then a comma and then give me the list. And then I'm going to use this to count how many there are. Now this is all advanced formatting. Don't really worry about it yet. We'll get on to how to do this more fancy formatting. But if I run this, we can see the Python keywords: false, none, true, and, as, assert, break, class. And I can scroll to the right. You can see all of them. So you see print isn't one of the keywords. Print's just a built-in function. So we can override print if we wanted. But if we tried to override any of these keywords, it would go, no, you're not doing that. That's a reserved word. It's going to be, you just cannot use them in your Python code. Okay, so we counted them. There are 33 keywords in Python 3.6.9. So Google, that's the version that Google Colab is using, so that's why I had to import sys, so I could find out what sys.version was. It's 33. Now, if you Python 3.8 is actually the latest you can download. If you installed that, you'd find there are 35 keywords, because it'll also include the keywords async and await. So be careful when you're writing Python 3.6 code. Don't use these as variable names, because when you try upgrading to Python 3.8, you will have trouble. Now, as we go through today, I'm going to see how many of these keywords I can cover, because basically those keywords define the language, and then anything else is just functions and libraries that you can learn to use. So the language itself is quite small. Like I say, only 33 keywords. And if you can understand what they do, then you understand the language. And then from then on, it's just learning libraries. Okay, so let's have a look at a couple of them straight off. There's a keyword here, none. So let's use that. We can use none as a value that we can put into a variable. And it's a value you want to give to a variable if you don't want it to have a value. So I've run that. And when I say, tell me what's in N, it's giving me nothing. It's saying there's nothing in it. but n now does exist as a variable. Okay, so none is the none value. Pass is a keyword as well. And there it is up there. And what does pass do? Once again, pass is nothing. It's like a no operation code. It's if you need to put a line of stuff in your code, but you don't want it to actually do anything, then you use the word pass. And there are, funnily enough, there are actually circumstances where you need to do that. But if I run pass, it'll do nothing. So I've just covered two of the keywords for you. So when you're naming your variables, it's often a good idea to use long variable names. It makes your code easier to understand, and it avoids clashing with the keywords, those 33 keywords, and it'll stop you from clashing with those built-in functions and classes. The convention in Python is to separate the words in your variable name with underscores and have the whole thing in lowercase. So that's different from, say, Java or JavaScript, where they like you to use camel case. So they don't have underscores, but they show you where the start of each word in the variable name is by putting a capital letter at the beginning. So if I store this number 345 into a long variable name, and then I type a long variable name to see what's in it, I'll get 345. All right, so while we're, before we move on to the next section, I'll just quickly show you, we're in IPython at the moment, but you could do this in Python console. And what's Python console look like? I'll show you this version. When you download Python from python.org, it comes with idle, which is a way of bringing up the Python console. Or if you are using it from the command line and you just type Python, it will bring up the Python console. So the Python console will look like this. So here it is, PyDev console. It'll have 3 greater than signs, and it's very similar to what we're doing in Google Colab. I can type a variable and give it a value, so a equals 3. I can type a and see what's in a, and it tells me 3. N equals none. Let's have a look at n. Nothing there. And this stuff here on the left, this is the Python console. So it's really, you can run multiple commands in the one go, but it's not quite as clear as those cells that we've got in Google Colab, where it shows everything in the cell and you execute the cell and any lines that are in there will run. In this, if you do 2 lines, it will generally run the first one and wait for you to then run the second one. Now, this is a bit small over here on the right, but if you can see it, this is one of the things that a integrated development environment will give you, as long as we've got the, as well as having this console on the left, on the right, we've got a list of all the variables that we've been creating as we've been creating them. So, you know, a long variable name equals 123. And we can see over here, it goes in blue, is the last thing that's changed. A long variable equals what the value is, 1, 2, 3. Even tells us n has got the value none in it. And it also gives a bit of extra information, which is the type of the value that's there. So that's an integer, and that's the none type. Okay, so that's all I'll show you about a console. Just so if you see these 3 greater than signs, then you'll know that's where you are, just in the old Python console. Right, so now we're in Google Colab. How do we find out the types of these values? And there's a built-in function called type that will tell us the data type. So remember, a was a variable, we put a number in it, and if I run that, it tells us that the type of a is an int. So it gives us that same information, it's just a little bit harder to get to it. And that's an int. Now we used a variable name here, so by putting a variable name, it then went to that value and pulled it out. We could have actually just put a literal value straight in there. What's the type of 456? and it tells us it's type int. So ints are integers or whole numbers. We can also have floating point numbers. Remember when we did the B calculation, it was, what was B? 4.5. That's not an integer or a whole number. That's got a decimal part. And so Python stores that in a different way, and the way it stores it is called a float. So when floating point numbers are stored, what they do is they store the mantissa and the exponent. So here's an example of a number. It's quite a big number, but it's a decimal number because it's got 0.0 at the end. And so the mantissa is this value here on the left, and then the exponent is this value on the right. So this number on the left will be a number between 1 and 10, or between -1 and -10. And you multiply that by 10 to the power 19, and because that's the exponent. So E says exponent, and it's 10 to the plus 19. And that's how, in a small amount of memory, they can store a very big range of numbers, because they just have to store this number there, which is only between 1 and 10, and between -1 and -10, and this number here, which then can be very large. Similarly, if we have a very small number, so this is between 1 and 0, then it moves the point all the way down to here. And that's really why they're calling it floating point, because you move the point around. And so it's 1.234, and here's the exponent here. So it's a very similar mantissa in both those cases, but the exponent's quite different, and that's why these two quite different numbers get stored, how they get stored. So that's 10 to the -14. So -14 says move that decimal point 14 places left. So I go 1, 2, 3, 4, 5, up to 14, and this plus 19 says move it to the right. So I go 1, 2, 3, 4, 5 to actually convert the number back to the non-exponential notation format. Okay, any questions about numbers? So text is stored as strings of characters, and in Python we can just store the strings using quotes, and probably different to most languages. They don't care whether you use single quotes or double quotes. You can even use these special ones, triple single quotes and triple double quotes. And you have to just make sure that you end your string with the same value that the same sort of quote that you started with. And you have to make sure that that quote isn't included anywhere inside the string itself, because otherwise it'll think it's come to the end. So that means that if you start a string with single quotes, you can embed double quotes in there. So here's a string with double quotes in it, and I've just defined that by putting single quotes at the end. Similarly, I might want to have something with single quotes inside the string, so I can use double quotes at each end. And it's really just quite flexible how you do that. If you use these triple quotes, you can even embed line feeds. So the string starts here, goes to here, and then it includes a line feed, and then keeps going. And it's also got single quotes in there and double quotes. So I've created these 4 strings. I've stored them in variable names S1, S2, S3, S4. And then I can print them out, and I'll print out the type as well. So let's run this cell. And there it is. So when I use print to display a value, it prints it as we would want it to be displayed if we're doing a report or giving some information to an end user who's using our program. Now, if we were looking in IPython at what's in the value S1, we would just type S1. So in fact, I'll do that now. So I'm going to type Command M B to insert a cell below, and I just type S1 and Shift Enter, and it says, and it displays the value, but it also puts quotes around it. It gives me a hint because it knows I'm fairly knowledgeable about Python because I'm using IPython. So it's telling me, well, you probably want to know what type it is, a bit about the type, so it's going to display it using these quotes as well. I can have a look at S2. And S2, it's put single quotes around the whole lot, and then it's got single quotes inside it. So not a very good way of displaying it because I can't just copy and paste that into my code. That's not going to work. I'm actually a bit surprised that it did that, but anyway, that's what it's done. And if I do S3, let's have a look at these. Yeah, so this time it's decided to use single quotes again, even though it was defined using triple single quotes. But it showed the embedded line feed with a \n. And this time it's gone, oh, I want to put single quotes inside my string. Therefore, I need to escape them so that it doesn't think that it's actually the end of the string. And so in this case, it's done \single quote, and that means don't look at it as a single quote in the sense of defining strings. Look at it as just the character of a single quote. So we'll have a look at a couple of these special characters. We've got \n as the new line, \r is carriage return, \single quote is for single quote, double quote, and if you actually do want to do a \, then you do double \. So let's have a look. We'll use the print statement here, the print function, and we'll do the number 1, then a comma, and then my special character 1, which is the new line, then a 2, special character 2, which is a carriage return, and we'll see what that looks like. So print with commas will print out each value separated by a space. So it's done a 1, then it's printed the new line, and you can see it's gone down to the new line. It's printed the 2, there's no 2 showing there. But then it's printed the carriage return, and what the carriage return does is it says, oh, I want to move back to the beginning of the line, but not another line feed. And then it's printed the number 3. So that's why we're not seeing a 2. It's actually moved back and overwritten the 2 with the 3, or the space 3. And then we've got the single quote, the double quote, and the \. And they've just printed out exactly as they are. Okay, so we're getting onto a bit more of an advanced topic here, so let me know if you're not keeping up. Some of these strings, when you're defining them, you can put a letter in front of the quotes that define the string, and that tells you a bit more information about the string itself. So if we put a U in front of it, we're telling Python that we're about to do a Unicode string. Now this is the default in Python 3, so you don't need to put a U there ever in Python 3, and I'd recommend you use Python 3, don't bother learning Python 2 because it's end of line no longer supported. But if you're writing Python 2 code and you want to use a Unicode string, then you have to put a U out the front. Similarly, if you want to write a byte string, which was the default in Python 2, if you want to use a byte string in Python 3, then you would use a B in front of it. And so byte strings you would use in electronics applications or communications with serial transfer, where you need to know about each byte of information that's being transferred. And that's where you'd want to use a byte string. But really most of your code you're going to use Unicode strings, so Python 3 is definitely the better way to go. Now some people are trying to write code that works in both Python 2 and Python 3. I think that's a mug's game, but people have successfully done it. And so they have to, everywhere they want to use a Unicode string, they'd have to put a U in front, and everywhere they want to use a byte string, they put a B in front. And that way it means it will work in both Python 2 and Python 3. Okay, now there's one here called a raw string, R, and raw strings are great if you don't want to get confused trying to do backslashes, because if you really do have a lot of backslashes in some text that you're putting into a string, then it gets really confusing remembering how you're having to double each time, and especially if you're then going to regular expressions, and then in a regular expression you have to escape the backslash with a double backslash, and then you escape the double backslash with a 4 times backslash. So what you do is you use these raw strings, and it just means a backslash is a backslash. It's not going to affect any other characters, and so at least as far as Python's concerned, you can be happy that what you've typed in is going to show exactly as you've typed it in, and it's not going to bring in any special characters. So I've made a string here with these backslash n, backslash r, backslash t, just to see what would happen. But let's have a look at what happens when we print it out. I'll run that, and you can see here the raw string, the backslash is just a backslash, single backslash prints as a single backslash, backslash n prints as a backslash n, backslash r prints as a backslash r. So that can be useful. It can be useful if you're wanting to describe these special characters. You can just type them in just like that. And the last prefix that you can put in front of a string is the F for a format string. Now this is a feature that only was introduced in Python 3.6, but it's been very popular. So if you use it in Python 3.6, people will, well, if you use it, people will know that you're really up with one of the latest Pythons, especially certainly the latest Python that's available on Google Colab. And what a format string does is it allows you to put these curly braces inside the string. And if you do that, it evaluates anything that's inside the curly braces. So here we've got a variable, it evaluates that and then displays the value. So if we look at what got stored in the string here, rather than storing the letter A or any curly braces, it stored the value of A, which is 3. And then it stored the value of B, which is 4.5. And then in this one, it's actually evaluated A plus B, worked out that the answer is 7.5, and then stored the result of that in the string. And so we've got 3 plus 4.5 equals 7.5. Now, I'm going to use these format strings quite a lot in these Google Colab sessions because it makes it easy to get really nice display. Probably makes it a little bit harder to read for newcomers. So let me know if you're having any problems understanding it. But if you do, just concentrate on what's inside the curly braces and maybe make a cell. So I'll do command below, make a cell, and just type in the cell, what's below, rather than trying to work out the full mechanics of that string. So yeah, just type A plus B and you'll see the 7.5. Okay, so operators, let's look at some of the operators, the mathematical operators that we can use with our variables, with our number variables. So we've got a few here. We've got plus and minus. So the star or asterisk is used in Python to mean multiplication. We can do a double slash, forward slash, and that's used for integer division or floor division. Percent sign means modulo or remainder. We want to find the remainder of a division. And star star is power. So let's print these results out using our fancy format strings that I told you I was going to use. And we have 27 plus 5 returns 32. 27 minus 5 returns 22. 27 times 5 is 135. So 27 divided by 5, and remember here we're now doing integer arithmetic. So we have an integer quotient, which is 5, and an integer remainder, which is 2. So 27 slash 5, or 27 divided by 5 is 5 remainder 2. And so using those two operators, we can get those two values out. Uh, 27 to the power of 5 is 27 times 27 times 27 times 27 times 27, and that gives us this value here, 14,348,907. So once again, try these in a cell yourself, just so you can be confident how to use them. So 27 slash 5 gives us 5. And let's have a look at what happens when we do slash 5. It gives us 5.4. So the slash is your integer division, and the single slash is your floating point division. So let's have a look at floating point operators. They're all mostly the same, but if one of the numbers that we have between of these operators is floating point, then the result is going to be floating point. So if either or both is a floating point. So we'll run the same ones as before, but now we've got a single slash as well as the double slash. So you can see every one of these results now is a floating point number. It's got a, even if it comes out with a decimal place of 0, then it's still considered a floating point number. So when it prints, they will all print with 0.0 after them, so that we know that they're floating point numbers. And really the only one that needed the decimal point was this 27 divided by 5 for the floating point division, and that gave us 5.4. So as you're looking at this, are you surprised by anything? Is there anything coming up that you're not sure about? Python can be a really good calculator this way. It's you can even use parentheses and the order of operations, so it will do your brackets, your multiplication, division before it does your addition and subtraction. So you can just write out your algebraic expressions just as you would normally in maths, and it would calculate them in the right order. All right, for some people who like something a little bit more advanced, there's some other operators. These are called Bitwise Operators, and they work on binary numbers. And so they're the pipe symbol, the ampersand, the circumflex, the double less than sign, the double greater than sign. So let's have a look at what they do. And I've done some really fancy formatting here. So I've got the value of A is 10, and 3, I could have done the value of B there, returns A bitwise 3, and then a colon. And anything in a format string after between the curly braces that's after a colon is gives you some idea how to format the result. So what I've done here, I've used this code here, greater than 2, and really just look up all the format codes because you're not going to remember all these. And what greater than 2 means, I want right justified and 2 characters wide. And you can see here, by doing that, it's meant that these have all lined up nicely. They're all right justified and 2 characters wide. So 10, bitwise OR 3 returns 11. Now how does it calculate that? So I've used format strings here to convert these decimal numbers into binary numbers. So I want A to display as a 4-digit binary number, and I want the number 3 to display as a 4-digit binary number, and I want it to be right justified, so I could have put right justified over there as well, and I want it to be 0 padded. So this one wasn't padded, so it was just, I didn't say what the padding was, so I assumed space, but this one I want to be 0 padded. So A, which is 10, translates to 1010, and 3 translates to 0011. And so when I do a bitwise OR on that, I just look at each bit, and if either of them is a 1, then the result is a 1. So the first bit, the result is a 1 because A has a 1 there. The second is a 0 because neither 10 nor 3 have a 1 in the third digit. Both of them have 1s here, so the result's going to be 1, and just the 3 has a 1 here, so that's going to be a 1 as well. So that gives us 1011, and if we convert that from binary back to decimal, that's 1 plus 2 plus 8, and that's 11, and that's the answer that we got, 11. Similarly, you can see how bitwise AND worked. 1010 and 0011 gives us 0010 because that's the only bit that has a 1 in both numbers. Bitwise exclusive OR means it's a 0 if both are 0 or 0 if both are 1, but if only one of them is a 1, then the result will have a 1, and that gives us 1001. Shift left 2 places means take our number, which was 0011, shift it left 2 places. So we shift everything left 2 places, we get 1100, and that gives us the value of 8 plus 4 is 12. And similarly, shifting right, 1101, shifting right gives us 0011, and that returns the value 3. All right, you probably never have to use that. I just throw them in as a bit more advanced. People who do electronics will be working with these sorts of things if they're using Python for it. Now, some of these operators, they work on strings as well. So let's have a look with a string. We've got the plus operator and the star operator. And we run this. So we've got the string well times 3, and it's gone well, 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 and then plus this other string, 3 holes in the ground, and it's created a whole string that's well, 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 3 holes in the ground. So we can use some operators with strings as well. If you're doing adjacent strings, you don't even need the plus sign. You can just do a string here that's with double quotes. Here's another string with single quotes. A string here with triple double quotes and triple single quotes. We've just left spaces between all of those, and Python's known that we wanted to concatenate them all up into one string. So some of the interesting side effects of the way Python does things. Integers can have more significant digits than floats because floats have just got a certain amount of bytes available for the mantissa, which gives you about 17 decimal places, and then the rest in the exponent. While an integer will just keep expanding to use the number of bytes that it requires. I was looking through an old Python 1 textbook I had on my shelf the other day, and in Python 1 we had to say how many bytes we were going to use for an integer, whether it was going to be a 32-bit integer or a longer integer. But now in Python 2 and 3, the integers can now just be as long as you like, and Python itself works out how many bytes to use to store the number. So what it means is that we can have incredibly large numbers stored in integers if we just don't store the if we just put lots of zeros in there to make sure that it doesn't get truncated. So for example, 25 divided by 7, which is a floating point, that gives us this number of decimal places. But if I do 25 and lots of zeros and integer division with 7, I get an integer that comes back which if I can just remember where to put the decimal point back in myself, it goes in here, then I can work out lots of decimal places after that. And I was playing around writing myself a program that calculated pi to 1,000 decimal places the other day, and I did that all with integers. I just kept getting these enormously long integers, and it worked. Okay, Nicholas asked me, why doesn't 1101 become 1011 when it's shifted to the right? And the reason it's not circular is actually to do with the number of bytes that is stored. Now I'm showing these as 4-bit values, but they could have been a 16-bit value. It could be a 32-bit value. Integers can be, just depending on the size of it. So if it's going to rotate, it's going to give us different numbers, whether it's stored in a 4-byte value or an 8-byte value. So that's not going to work. People who use the shift right function, this is actually the behavior that they're looking for. I'll just throw an 8 in there. So and I want that 0 padded. Yeah, so I've got 4 zeros, 1101, shift right 2, and that'll shift right to the 2 as well. And give us the same number. So you get the same answer regardless of how many bytes are being used to store that number. It's not, the shift right and shift left's not something that I use that much. I'm trying to think if I've ever used it. Maybe in calculating checksums I've used it, and in which case I haven't needed any circular shifting to happen. You imagine if you shift left by 2, it's actually the same as multiplying by 4 in binary. So 3 shift left 2 is actually 12, which is multiplied by 4. And when you shift right 2, that's the same as dividing integer division by 2 squared, which is 4. So 13 divided by 2 squared is 3, remainder 1. So they're not really essential operators, because you could have just done integer division with the power of 2 that you needed. All right, now floating point numbers, you have to be a little bit careful because binary numbers can't store decimal numbers exactly. So when Python is storing a float in decimal, in binary, it has to truncate the number often, in which case then when you get the number back, it's not going to be the exact number. So here's an example. If we have 1.1 plus 2.2, and that returns 3.3000003. So it doesn't store them exactly. That's great for scientific. We don't need it to store exactly. It's just really good to have the ability to have lots of decimal places. But in accounting, we only want a couple of decimal places, but we want it to be exact. So in that case, you don't want to use floats. Your options, if you're doing an accounting software, you just either convert everything to cents, for example, and use integers. Or if you want to use dollars, there's a class called decimal that you can use for accounting. So I'll just make another cell below this. I'll do this properly. I select this cell, I say Command MB. So if I look at what 1.1 is, 1.1 does display exactly as 1.1. And what Python does, even though it's not stored exactly, it goes, all right, so 1.1 is actually 1.10000 and up to 1. It's got a range of numbers, and the range of numbers that it could be stored in this number of decimal place, in this number of bytes, is going to be from slightly less than 1.1 to slightly more than 1.1. So what Python does, it goes, well, if 1.1 is included in that range, then it'll just display 1.1. And similarly, 2.2 will display correctly. But both of these numbers are actually just slightly on the high side. So by the time you get to adding them together, it's pushed it out so that the resulting binary number cannot be used to represent 3.3. It's a different binary number to represent 3.3. And that's why Python goes, okay, I now have to just show all the decimal places in this situation. All right, so here's challenge 2. Challenge 1 was getting Python running. Challenge 2, I've left some blank cells here. So have a go at these yourself. Add 123 to 456 and display the result. So adding, where you're going to use the plus operator. These are just integers, we can just type them straight in. So what you can do, you can either pause the video and have a go at them all, because I'm about to work through the solutions, and then you can see if your solutions are right, or you can, and maybe when you start playing it, play at double speed so you catch up to where we are, or you can just watch it, or even just have a go if you're quick enough to do it while I'm doing it. So 123 plus 456 gives us 579. So that's the answer. Now, integer quotient. Remember, when you're doing integer quotient, where you have to use the double /. And that gives us 2836. Oh, and we want the remainder. What we can do here, we could, if we do them on two different lines, it's only going to print out display the value of the last line. So what we can either use a print statement, as I'll show you down below, or Python lets us put several expressions on the one line and separated by a comma. And so it displays the two results. So it's 2,836, remainder 206. 2 to the power 10, 1024. Decimal quotient is just the same as the integer quotient with a single slash, 2836.876, etc. Okay, store in a variable the name of your favorite programming language. So let's go S1 equals Python. Construct a new string that starts with programming in, finishes with is fun, and includes the value of the variable in the middle. Now, there's a few ways that we can do this. We can say programming is programming in S1 is fun. And it came back with a new string, programming in Python is fun. All right, now I provided some solutions here using format strings. Okay, so I actually used exactly the same way of doing the strings. So maybe we'll do if you want to do this using a format string, this is how we do it. So we put an F out the front. We don't need quotation marks there. We put curly braces around the variable that we want to evaluate. And that's done the same thing. Programming in Python is fun. So let's run these solutions. use the plus, we use double slash and modulo, we use star for power, floating point division, and string concatenation. Okay, so we've done integers, we've done floating point numbers, and we've done strings. So let's look at another data type we've got, which is the bool. And a bool is a Boolean data type that stores either a true or false. And it's usually a result of some sort of test that you've run using a conditional operator. So we can test to see if two values are equal, if they're not equal, less than, greater than, less than or equal, greater than or equal. And there's even some more tests we can use. These are some of the keywords in Python: in, or, and, not, and is. And they can be used to check if something's in something, something, or something, or something. So let's have a look at some examples. So the literal value is just true, and in Python it's capital T on true, capital F for false. Once again, two new keywords that we're looking at, and so you can see they're in blue. And both of them have the type bool. Now, I'm using conditional operator equals. On the left-hand side, I put the number 3. On the right, I put an expression 5 minus 2. And it's going to compare to see if the value, they have an equal value. So does 3 equal 5 minus 2? That is true. So is 45 greater than 23? That's true. Is minus 10 less than minus 20? That is false. Does C1 equal Python? And that's true. Okay, so challenge 3, I've put all these conditional statements here. So see if you can predict what is going to be the result for each of those. So once again, pause the video if you want to try to work it out, or just follow along. So I've run that, I thought. Let's try again, press play. Okay, C1 equals Python. That returns false because C1 is Python. So you can see the difference here is that that's got a capital P and that's got a lowercase p. So equals with strings is case sensitive. C1 does not equal Python, that returns true. So it's going to be the opposite of that one. All right, 253 is greater than or equal to 1518 divided by 6, returns true. Sounds good to me. So 253 less than or equal to 253.0 returns true. So you can have an integer on one side and a floating point number on the other, but if they're the same value, then the equal still works. So that's good to know. Now in the maths library, we've got some constants. We've got the E constant, which is the base for natural logarithms. We've got the pi constant. So if I hover over it, you can see E is 2.71828, blah, blah, blah. It's a rational number. Pi is 3.14159. So we can check, we can compare is E less than pi? And the answer is true. Now with these conditional operators, you can actually string them along, and it just checks that they're all, every place there's one will be true. So we're looking math.e is less than math.pi times 2 is less than math.tau. And tau is just really 2 times pi. So those two should be equal. So that being less than that is going to be false. And we get the answer false. All right. Compare lowercase a to lowercase c with a less than sign. That's true because we're comparing on Unicode values and a is less than c. So that's useful for sorting. We can, in alphabetical order, we can do comparisons like that. However, if I compare a to uppercase c, that returns false for less than because uppercase characters appear before lowercase in Unicode. So something to be aware of. So upper is less than lower. That returns true. Yep. Catch less than carriage. It goes through the string, one character at a time. C is the same, A is the same. T is less than R. That's false. So the whole thing returns false. Similarly, you can do the same thing with lists. We haven't done lists yet, but here is a list of numbers. We're going to compare that list with this list. 5 is greater than or equal to 6 is false. So it returns false because list elements are compared left to right. Now here's the keyword in. We want to see are the letters AT in catch, and that is true because AT, we can see it there. Is AC in catch? That's not true because the A and C are not adjacent and the C after the A. So that has to be a substring for this for it to return true using in. Similarly, TA is false. 2,6 not in that. You can't do this with lists. You can only check one element of a list at a time. So I could have said is 2 in this list, and that would return true. Is 6 in there, that would return true. Is 2,6 in there, that returns false. So not in returns true. You can use true or false. You can use the or between these conditional operators. So true or false returns true. True and false returns false, because that requires both of them to be true to return true. Now, if you want to do true or false and false, then that actually returns true. And the reason is because and has precedence over or. So if you've got a few ands and ors, you do all the ands first, work out the results of them. So false and false, the result of that is false. And then you do the ors. So true or, and the result of this, which was false, true or false, that returns true. And that gives us our overall answer of true. But similarly, if you see the same thing, we change the order, false and false or true, still returns true because the and still has precedence over the or. C1 is C2 returns true because they refer to the same location in memory. Now that's a fairly advanced thing to concept to be aware of. So here you can see C2 equals C1. Normally you'd use equals equals if you're comparing two values, but just occasionally you want to know is something in the same location in memory, and that's where you'd use is rather than equals equals. And so in this case, because I've said C2 equals C1, I've forced the string C2 and C1 to both point to the same parts of memory. And so in this case, they will be true. This will be true, but it's possible they could have the same value string, same letters in the string, and be in different parts of memory, in which case C1 as C2 would return false, but C1 equals C2 would return true. So don't use is unless you really know what you're doing. Okay, I said we get onto lists, and here we are. This is a more complicated data type. The way we define a list, we use square brackets at each end, and then we have a comma separated list of values, and they can be of different data types. So here we've got string, integer, floating point, and then a few more strings. So if I print that list, it prints it out. That's printed, it's printed single quotes, but it's still showing that they're strings. So we can just print a list directly. Lists are zero indexed. So to refer to a particular element in our list, we use an index inside square brackets. And so list square bracket 0, close square brackets, is referring to the first element, 6. List 1 then should give me 5. List 6 should give me 0. Now, one thing you can do with Python indexes, which is a lot more powerful than other languages, is you can count the index back from the end. So if you say -1, it will go 1 back from the end and give us 0. So in other languages, we'd have to calculate the length of the list and then subtract one from that and use that index to get the value. But in Python, we can just use this -1 shorthand. Similarly, -2 should give us 1. If we want to find the length of the list, we use the len function as a built-in function, and we just put in there the list that we want to find the length of, and it tells us there's 7 elements. So remember, if we wanted to find this one here, we'd go the length of that, which is 7 minus 1 to give us 6, and that would give us 0, and we know that list 6 gives us 0 because we tested it just here. Now in the indexes, we can slice them up by using the colon notation. So we can say I want all the values in the list from 2 to 5. And what does that give us? It gives us 4, 3, 2. Now the way I like to think of the index in a list is that it's just between the values. So here are the indexes. They're the positive indexes. Here are the negative indexes. So if I go 0, 1, 2, 3, 4, 5, 6. So remember we did 6 gave us 0. So whenever we use just a single index, it gives us the value just to the right of it. But this comes in really useful when we're doing slicing, because if I want to do 2, 5, I want to go all the values from 2 to 5, and that gives me these 3 values here, 5, 3, 2. Oh, sorry, 4, 3, 2. So if you think of these indexes as pointing to the commas between and at the ends, then you'll become a lot more comfortable with this 0 indexing, and also the fact that the 5 we go up to, but not including the value that's index 5, which in this case is 1. It gives us the advantage that to know the number of items in the slice, we can just subtract the 2 from the 5, and that's 3, and so we know there's going to be 3 items in this list. Now when you're slicing, if you're slicing from the beginning, you don't have to put a 0 in there, you can just leave it blank. So just go everything up to 4. Probably more useful is if you want to go all the way to the end. I'll just better run that. If you're going to the end, you don't have to put the last value in, because you often don't know what the last value is. You'd have to calculate it using the len function. So you go 3 colon all the way to the end. You can use 2 colons, and what that allows you to specify 3 numbers, which is your start value, your stop value, and your step value. So we're going to say start at 1, stop at the end, so we're not going to specify it, and go up in 2s. So that gives us 5, 3, 1. So very succinct notation here, very concise. So it's really quite powerful what you can do with this slicing. So for example, if I want to start from the last item and I want to go back to the first one, but not including it, and I want to go in -1s, then I can slice backwards from the end. So I go 0, 1, 2, 3, 4. So that's, I've now turned the list around and just included all but the last, those 2 values there. All right, and I've got list just by itself here. So all these things we've done to list, haven't made any changes to it. There's still our original list. But now, if we use the index notation, we can assign values to particular spots in the list. So if I assign 2 to the word 4 rather than the number 4, we can now see that the list, we've replaced the digits 4, the floating point number, with a string, FOUR. And similarly, I can replace the 0 with blast off. I go 6, 5, 4, 3, 2, 1, blast off. If you want to delete an element from the list, you can use the delete keyword. You see delete's in a special color because it's a keyword. So I say delete and the third element from the list, and then what's in the list after that. And you can see this value here has been deleted. All right, now strings can do a lot of the things that we've done with lists. It's like a sequence of characters, just like we have a sequence of elements. So we can do slicing in a string. So 3 to 7, that gives us D, E, F, G. So remember, 0, 1, 2, 3 takes us to starting at the D, and then up to 7, 4, 5, 6, 7. So it's D, E, F, G. That's what's included with slice 3 to 7. So our challenge here is what is something you can do in a list that you can't do with a string. So let's have a look. We can refer to an element in a string. We can, which we've done there, we can refer to the last character in a string. All right, let's try a few of these things out. So we've got our string A, B, C, D, E, F, G, H, I, J. Let's see if we can refer to the first character in that, and that's A, and we can. We can refer to the last character, -1, gives us J. We can refer to a slice of characters, which we've already tested. Can we do that backwards? Let's try. There we go. That does the whole string backwards. Let's try finding the length of the string. It's 10 characters long. That's good. What about if we try to assign a value to, say, there. I'll put a Z in the string. All right, so there's something we can't do. We get a type error. String object does not support item assignment. And let's run the solutions that I've done here. We've done a different string, 654321. Yeah, we can look at indexes, negative indexes, length, slicing, forwards to the ends, in steps, backwards. And then I didn't run these ones, the type error. I don't like leaving these notebooks with errors in them because if someone tries to run the whole lot, it will stop when it gets to the line where the error is. So that's why I didn't. But by doing it here, we can see that's a problem. And also, if we tried using delete, string object does not support item deletion. So that's another thing we can't do. So I'll just get rid of that error. And 5. Okay. Now we've done a few data types here. You can actually use, you can change data types, convert from one to another just by using the name of the data type. So like if I had the integer of a string with the number 56 in it, it will return 56. Or I could convert a string of the integer 56 and it will give me a string where the value is 56. So here's another one. We can do a list from the string. And if I do convert the string S, which is, if I hover over it, it tells me the value 65432210, and I convert that to a list, this is what I get. It actually takes each character out of the string and puts it into a separate element in the list. And that can be useful at times. And the reason it's done that is because S is what they call iterable. Strings are iterable. And so it'll iterate over that list and put each iteration as another element into the list. If I try to convert back to a string, you'll see I actually get a different value than what I started from. If I really wanted to convert back to the original string, I'd use this function here. And so this is an advanced topic here. I've used the empty string, so it's just two quotes and nothing in between them. And I run the join function on that joins all the elements of the string of this list, I joins them using an empty string, and that will give me that. I could have used dashes to join, and that will give me, as you can see what it's doing, so it puts dashes in there, and that's why I'm using an empty string which doesn't have dashes and gives me my original string back. All right, so now let's get on to some programming. We've been using interactive Python and just doing one-line commands. You've seen in a few of my solutions, I put a whole bunch of lines in the same cell, and it just runs them one after the other. And that's really all a script is. It's just a bunch of lines that it runs one after the other. But to do something more interesting in a script or a program, you want to run some lines sometimes and other lines another time. So in this case, we can use if, which is another keyword. We're going to use this library here, random, to generate some random numbers. So rand range 6 returns an int between 0 and 5, and we want to have a die roll that's going to be a number between 1 and 6. So we're going to check the roll, and we're going to see if it's even or odd. So the way we're going to do that is we're going to do the modulo with 2, and even numbers we know that when we divide by 2 the remainder is 0, and odd numbers the remainder is 1. So we do if, and then we have a condition, and so we use one of our conditional operators there, and so we know that this is going to return either a true or false. And then we do a colon, and so the colon says we're about to start a code block, and the code block is some indented code. And this is where Python is a bit different to other languages, as you work out what the code blocks are just by the indentation. Now, I'd recommend doing 4 spaces is the generally used thing in Python. I think I've had to change Google Colab to do 4 spaces. You might find that it's doing 2 spaces for you. 2 spaces will work, so you don't need to change it. But if you're trying to write code with other people, then use 4 spaces because that's what they will be using as well. So if it's even, we want to say it's an even number. If it's odd, it's odd. So let's run that. And it says you rolled 2, which is an even number. So it ran this bit of code because that was true. And then the else is part of the same if statement. And that gets run if this condition results in a false number, in which case it would say that. So let's run it again and see what we get. 6, which is even. 5, which is odd. So that seems to be working. Now the if, you can also combine a few if statements together. So we have if the first condition. So if they are, if we're going to do 2 dice rolls here, we're going to store the results in a list, and then we're going to refer to each of by their index 0 and 1, and then we're going to check whether they're equal. Else, we're going to check if the first one's less than the second one. Else, but only one other else is that the first one must be greater than the second one. So we use elif, which means else if another condition. So you roll 1, 4, first roll is less than the second roll. So that seems to be working. 5, 1, first roll is greater. 4, 3, 5, 3, first roll. And eventually we might get a double. Maybe not. 2, 2, they're both equal. So yep, our code seems to be working. So this code block is ended when the indentation ends. So then we started a new command, and we have another colon to start a new code block. And we can have several commands in each code block, and they're all indented, and they will all run until we get to the end of the code block. Okay, so we can also do loops, pretty similar. I guess this is really a very quick introduction to these programming structures because you've covered a lot tonight, so I'm not expecting you to remember all this stuff now, but it gets you into a bit of programming and you can refer to it, and then in other sessions we'll go through these things in more detail. So a loop, we use a for loop, and the format for for is we create a variable name here, and every time we go through the loop, this variable is going to have a different value. And then we say in, and we give it a range of values, a list of values that we're going to use. Now that can be anything that's iterable, and so lists are iterable. So in this case, the first time it goes through the loop, number will have the value 3, the second time 2, the third time 1. And there we go, prints 3, 2, 1. So loops are really good for repeating code, so you can get a program to do quite a lot in a short, with just a few lines of code. So that's the for loop. I'll quickly do what a while loop. A while is a combination between a for loop and an if statement. So while means it looks at a condition, just like in an if, and then it will keep doing that loop here. So everything that's indented, even stuff that's indented twice, will get run over and over again in this while loop. There's nothing, and then it just falls off the end. So make sure there's something happens in your while loop that's going to eventually make this turn to false. So we've got counter is 0, counter is less than 10, that's going to start off true. And then we've got counter equals counter plus 1. So we're going to keep incrementing counter and until counter is greater than 10. So let's run that. And we've copied in here our code before. So it works out which code block it's going to run based on this if statement. And it says whether the first roll is greater, less than, or equal to the second. Okay, so our challenge 5 is write a program which prints every number from 0 to 20 as digits and its name in words, as well as whether it is even or odd. Okay, that's a lot. Okay, so I'm going to put in there's a few different ways I could do this. So just using what we've learnt already, I'll start off, I'll say with I equals 0, and then I'll just go for number in numbers, print, and I'm going to print I'm going to print number, and I'm going to, no, I won't do the even or odd now, we'll do that later. Okay, and then next time through the loop, I'm going to increment I to 1 by 1. So I could have said I equals I plus 1, or I could say I plus equals 1. In numbers, all right, so what I've done here, I haven't executed this one, and I can see that because there's no number in the square brackets just there. So I better run that, and then I can run this. And that's printed the number and its name, 0, 1, 1, 2, 3, 4. So that's a good way of doing it. So let's have a look at the solution here. This is a solution using a while loop. And while I is less than the length of numbers, so numbers was going to be 20, so while I is less than 20, actually what numbers are going to be, the length of numbers are going to be 21. There's 21 values in there because we include 0. I then check if it's even or odd, and then I just print those values. So there we go. 0 is even, 1 is odd, 2 is even, 3 is odd. And you can see here, this is really a useful way of converting a number. I've got a number I as an integer, and I convert it to its name just by looking it up in a list. So number 6 is SIX. All right, so now I've mentioned before, if you want to do accounting applications, you want to use the decimal type from the decimal standard library. So we could use that by just importing decimal standard library, and then we can refer to the decimal type in there because it's inside that library. So this name here, the library decimal, we prefix decimal dot, and then the class name decimal, and then we provide what the decimal numbers are. and we have to provide them by string. Seems a little bit counterintuitive, but the problem is if we use floating point numbers there, then Python will jump in too early before the classes, before we've created our decimal, and it will put in all those extra decimal places that we don't want. So we use strings in this case, and let's have a look at what decimal 1.1, and I better run this, I keep feeling, and I get decimal 3.3. So that solved our problem we had with that using floating point arithmetic for accounting applications. Now when we're using these standard libraries, sometimes there's only one thing that we want to import from the library. In this case it's just the decimal class. So we can say from this standard library, just import that one class. And then it means that whenever we want to use that class, we don't have to prefix it with decimal.decimal. So in that case, we can do slightly shorter syntax, decimal 1.1 plus decimal 2.2 gives us decimal 3.3. Now, even typing the full word decimal is a bit laborious, so sometimes we want to create a shortcut, and that's where we use the keyword as. And I'm really just doing this to throw in a few extra keywords so we can see how many keywords we can cover in our short session tonight. So, from decimal, import decimal as D. Now we can just type D 1.1 plus D 2.2. And it's actually becoming usable if we needed to. The result still shows the full decimal class name, but when we're typing code, we don't have to type so much. So that's given us the from keyword, the import keyword, and the as keyword. And when you're doing data science, you'll see quite a lot. They import a whole library, pandas, as PD, and then it means that, so these are like aliases. Whenever they want to use pandas, you just use PD. So this was a class as an alias. This is a whole library as an alias. All right, so that's the end of the session. Let's have a look at, these are all the keywords we covered. So you should be able to just look through those and know what all of them do. Let's count how many there were. There was 18 out of the 33 keywords. So, you already know more than half of Python there is to know. So I hope you found that interesting. There was quite a lot to cover. If you've got any questions, I'll still be listening to the chat for a few minutes after I've finished. I think the YouTube chat will stop working as soon as I stop recording, but feel free to ask questions on the Slack chat, and feel free to get an account. Just send an email off to SkyPi and she'll set you up with an account on Slack so that you can follow in Slack. Next week will be it'll be run by Arun, and he'll be doing machine learning. So if you want to have a go at machine learning, he'll be using notebooks again, so you don't need to install anything. But he'll be doing the next 2 weeks, and then I'll be getting back and just doing rudimentary Python stuff. Not sure what I'm going to be doing yet. So yeah, leave comments. And any feedback. If there's something that you really want covered, just let us know as well, and we'll see what we can do. Okay, thanks for listening.